So yeah, I'm with CloudFlare. I'm not doing a lot of enterprise. That was very enterprisey from my perspective. So sorry, I'm not going to have all the cool, as much of a cool talk like Sine did. But I work for CloudFlare. I've been there for 3 months. Historically, I've been pretty much a long haul routing engineer. So I'm going to talk to you a little bit about some of the challenges that we have in our environment, and also something that has been spearheaded by our company called Project Galileo. Are you mostly bloggers? Who are you guys?
I would say we're engineers first.
Okay. Okay.
And then some people who have rather popular podcasts and bloggers, blogging, and
know more about who you guys are. I probably would listen to your podcasts and follow your blogs. I'll find out who you guys are later. But anyway, so I'm at CloudFlare. So basically, we are a proxy caching company. We don't host. We don't do hosting. We're not a rack-based company, but we're doing basically proxy caching and also DNS. Bare bones, HTTP or DNS. That's all we're doing. And we run basically an Anycast network. Okay. And so the idea here is to provide performance, to provide basically infrastructure that a lot of other companies have out there, a lot of major companies have out there, where they have presence in many locations around the world. So when a TCP connection or a DNS query is done, you're doing it locally or regionally in the area, and it's not coming all the way back to the United States. Or even here in the United States, you're doing it regionally. Let's say you're in Chicago, your connection is done in Chicago. We also have a lot of little techniques about handling DDoS attacks. We have scattering. There's a lot of mitigation from amplification attacks that we have, not just at the server level, but also at the edge. And also also the Pluribus has played a great role there because of the deep buffering that it has. So when you also have a lot of unwanted traffic, you're still able to handle real traffic. So we have 28 sites worldwide. We're in Asia, we're in Australia as well. We're constantly expanding. If you notice, we're not in Africa. But we also do have presence down in South America as well. So we use a technique called IP Anycast. So it's the same IP address that's getting announced from all 28 sites. All of our servers can answer the same IP. We're not doing any virtualization, so all of it's very bare metal, and we like it like that. But we do containers for certain occasions, so there is some virtualization in that sense. But so the idea here, also we're v6, v4 dual stack. So if you basically want to run a website with v6 capabilities and not want to have to deal with the expertise to do that, we have connectivity to many transit providers who are also running dual stack, and also we peer. Most of our peers are v4, v6 with just about every provider. There's probably a few caveats there, but yeah. So the idea here is that your TCP connection is sped up because we are closer to the eyeballs. So that's what that last graphic is. I'll just keep speeding along here, just give you guys an idea. So the idea here is that if you have traffic in Germany, it stays in Germany. If you have traffic that originates in Frankfurt, if we're connected in the proper way with other networks, whether it be transit or whether it be peering, there's a lot of options to us because there's public fabrics and things like that. So if we start figuring out ways to lessen our dependence on transit, we are also hopefully lowering the amount of hops and the amount of latency between us and eyeballs. So we've also connected to a lot of public fabrics as well. There's DKIX, there's AMP6. Equinix has a lot of public fabrics here in the United States. And so that means hopefully you're starting to regionally route. But what I found out coming here is that it's still the Wild West. You don't have complete control over how people get to you. There's BGP tiebreakers, there's ways of using communities, there's ways of prepending, but still there are a lot of relationships and there's a lot of ways that providers can still prefer certain routes over another. Things like local pref is usually the first tiebreaker in BGP. we have absolutely no control over that. So we have to figure out ways to connect to other networks, and I'll show you a little bit more about it. I'll talk to you a little bit more about how that happens. But here, well, it showed up pretty good on the monitor. I didn't know if it was going to, but basically you can see we have the same IP address here, destination IP of 173.245.61.248. It's also down here. This starts maybe from somebody's, this could be, let's say you're traveling, this would be your hotel here in Singapore, and then you go to Hong Kong. See, it's the same IP address that you're destined for, but the path is completely different. So, which is nice because, let's say for instance, Singapore disappears, you could still be served out of Hong Kong. I'm showing here really low latency times, but here's Dubai. We have no presence in the Middle East. So this gives you an idea. This is round trip. It's not just, that's RTT. So you can see that there is latency that can still happen from certain parts of the world because we're not fully there. But here's Wellington. Again, the same IP address, completely different path from where you are geographically. Wellington being in New Zealand, and there's no pop down there. Perth. Our technical lead is from Australia, so I decided to use some of his stuff. But here you can see that the DNS question. It's really interesting being here because we actually start to see very commonly whose DNS servers are used, because usually this is usually somebody's like Verizon's or Comcast resolver. So the eyeballs actually make the request here to the first DNS server, and so we actually have an idea about who commonly requests DNS, and a lot of it, and we also know what is noise based on that. Like Google has open resolvers, so we see heavy amount of DNS traffic from them. For the gray hairs, you probably know that Level 3 has some open resolvers too, because they've been around a lot longer. But so this is the path that a DNS request would be made. It would be, let's say for instance, last year it's not known, so it would make it to the closest pop here, hopefully, based on routing, but there definitely are a lot of anomalies where that we don't have control over. So once the DNS request is made, the TCP connection is also made because it's also an Anycast IP, and the response is brought back. But let's say, for instance, Frankfurt goes offline. DNS doesn't need to be requeried because you already have it cached here, but the TCP connection then would go to Amsterdam. So this is the headache of where I work now. Because we have to figure out, first off, based on transit, we have to figure out who we're connecting with, how they're connected to other providers, and also we also use our transits to mitigate DDoS attacks by sending action communities, and there's also ways of using route servers as a way to, we call it null routing essentially. It could be like a /32 IP, let's say it's a common destination. So the way the internet works mostly between transit providers is we call it hot potato routing. So if we have an East Coast and West Coast, let's say you have provider A and provider B, and they're connected both on the East Coast and West Coast. If traffic enters on the West Coast and is destined for the East Coast, provider A will drop it to provider B as quickly as possible, which would be on the West Coast. So yeah. Also, transit is generally usage-based, so starting to figure out a mixture between transit and peering is one of the things that we're trying to do. So this is some of the headaches that we have to deal with. So for instance, let's say for instance you have a customer in the European area. They might eventually be a peer in Asia, and we have to figure out basically, are they, sometimes providers just peer just in the United States at one point, and we wouldn't send them Anycast routes because that would significantly mean that they would go just to the United States instead of staying in Europe. So we have the ability to prepend, like I mentioned before, there's a lot of tiebreakers within BGP that we use. So this is types of things that I work on daily. And so yeah, there's also action communities to do black holing and null routing of particular routes. Telia has actually published their communities if you want to see what they are. They're extensive. I mean, it could be, we could even send them communities to say, hey, we want to stop announcing to level 3, or we can, there's a lot of different options to control routing. Europe and Asia is pretty well connected. There's a lot of common connections, so we don't have to worry too much. Asia can be a little bit more segmented. I'm sorry, Europe and US is pretty common, but Asia has a lot more segmentation. There's incumbents that are in Taiwan or in Hong Kong, and pretty much you have to pay to connect to the networks, but they might freely peer with you in other markets. So that's that. In North America and Europe, what we commonly see is the eyeball networks like Comcast, AT&T, Verizon. They want to connect to you, and they want to charge you for connecting to their networks. They won't peer with you directly. In Europe, you kind of see the same behavior between some of the incumbents here, like Telus and Era, in their own markets, like Orange, France Telecom, and things like that. So there are these public fabrics like AM6, DKIX. Links also is an interesting case where they might exist between many buildings in London, but they also have layer 2 fabrics that extend out into, say, Wales or Cardiff, or which is really nice because you can connect with providers out there and peer with them directly through the layer 2 fabric. Asia is interesting. The HKIX is really nice. In Hong Kong, you pretty much have a view of 100% of Hong Kong, so it's very easy to keep traffic regionalized there. That's kind of like that's the common problem with us, is trying to keep traffic regionalized instead of some Asian provider using NTT, and then the way they connect to other Asian networks is coming back to the United States, so that's the tricks that we have to figure out, is making sure like traffic doesn't come back here and then go back out to Asia, or traffic from Asia just ends up here in the United States and drops off at, say, LAX or SJC. So these are the types of things that we do. I can keep skipping through some of this stuff just based on time, but So some of the challenges we do come up with is I think I mentioned this before, is where there's an ISP in Germany, they ask to peer with us in New York, but they don't peer anywhere else. So instead of just using Anycast, they will probably prefer the prefixes from the peer. We don't want them coming all the way to New York. And we also launched an interesting project, just to kind of caveat, just a little bit of time here, but we're using the right probes right now, which there's many out there, but we've used about 3,000 of them. You can start, after a certain amount of credits of usage with them, you can actually start using them, their API, and then from that you can start querying, and the probes are all over the world, so we can start seeing like what DNS server is getting queried from what region. So you also know where the probe is located, and based on that you can figure out, like, if somebody's in Germany, are they actually using Frankfurt's probes? Is that where they're hitting? Nope. Oh, they're sometimes appearing over in say Paris or something like that. So we're using that data to kind of figure out some of the challenging points of, like, where we're connecting, where customers are originating from, and how they're reaching our servers, our bare metals. Also, ISPs do a lot of crazy stuff, like strict reverse path forwarding, which really wreaks havoc. Sometimes there's ECMP, where they're using per packet, like true per packet load balancing, where one packet goes one way and the other packet goes out another interface, and they're usually two different providers. We've seen stuff like that. And then the next challenge, also some of the challenges we have, is moving and deploying into new markets. China, of course, being a huge market of huge interest. So in the DDoS mitigation world, just to kind of give a little slide about this, we start at the NIC level. There's programmable NICs where you can actually add filters right at the NIC. There's a lot of tricks you can do now with IRQs, and using Linux, for handling multiple IRQs for different types of attacks. Best thing to do is try to cut things off before it hits the metal. And then also at the data center edge, we're also doing we're using FlowSpec as a way to, which is a BGP construct. It's using BGP signaling to enter firewall rules, which could be rate limiters, it could be just flat out drop this packet. And then also at the provider edge, we can also send action communities, BGP communities, up to the provider route server or good old phone call. And then just to kind of, I have 4 minutes, so I was going to talk a little bit about Project Galileo, which was great because this is good that I was asked to actually add these slides, and I talked with our council to get a better idea about what the idea behind Galileo was. I knew that it was spearheaded. I knew what it looked like from more of like a user standpoint, but I also wanted to see what some of the history was and why we actually took the time to even implement something like this. And so the Project Galileo, there's actually a website out there, projectgalileo.org, that will take you to our site and explain in pretty good detail. Chris, I'd like you to look up here first, but no, I'm just kidding. So the idea is that we had politically and artistically important sites, and it was sometimes hard to designate what those sites are. And so we decided to create this type of program so partners can decide what sites are considered politically and artistically important. And I believe we had a blogger that was in the Ukraine that their site was under a heavy DDoS attack. Well, we're in the mode of, we're a company. We're supposed to be making money. So that's like our prime directive. So if we have a free service, if you're getting DDoSed, we have a threshold of how much DDoS traffic we would handle, and then after that we don't handle it anymore, and it's passed on to your origin server. So it could be wherever you are. It could be a rack space or Linode. I'm not sure the details of where this guy's server was, but we actually usually sit as a soldier in front of that. But if you're a free customer after a certain threshold, we just say, we just drop any DDoS mitigation capabilities for you. The blogger got very hysterical, very angry. He was very vocal. And sometimes we're not very familiar with even what the political agenda is for some bloggers. I mean, it's pretty amazing being here because there are sites that get attacked, and sometimes it's just a free, like a voting, like to get people to come out and vote. And you're like, why would somebody attack that? So it's very interesting being here because you start to learn that there's a lot of other there's a lot of things in motion in this world, and it's not necessarily, sometimes these sites are in Cyrillic, they're in different character bases, and can't understand even what they're saying. Even Google Translate has trouble with them. So we felt that the Project Galileo was a great way to build an awareness for, first off, what we do, and also it's been a great way to become the soldier in between these and mitigate these DDoS attacks, because first off, we learn a lot about the attacks, we learn a lot about where they come from, and we also learn a lot about the techniques used. What types of packets are used, what's the rate, how do amplification attacks work. So we're also testing our ability to mitigate, which is great. And most importantly, it's the right thing to do. We just felt it was a way to promote the idea that you shouldn't bully somebody off the line. Even if you disagree with them, they should be able to have the ability to freely speak. So these are some of the partners that we partner with. And you can't come directly to us and get designated as somebody who's politically or artistically significant. We allow our partners to define what that is. And so that's, if you happen to know anybody that wants to become a partner, we're open to that. If you were actually wanting to be recognized as a blogger under this, we would send you the partners. So that's it. that's basically the tagline for that project. And yeah, thank you. I'm open to any questions if you have any.